for the March 24th lecture on periodic functions. So go ahead and get started with a little bit of review of right triangle trig. I'm hoping everybody saw a good amount of this back in geometry. So hopefully this is mostly a review, but I'm going to teach it kind of like it's brand new, but I'm going to go kind of quick here. So you should have your notes out. If you don't, pause your video, get your notes out, put today's date up at the top, just like this was a normal lecture, and sketch this triangle. So this is a right triangle. We want to find the values for b, y, and x, and we can assume this is a right triangle. It looks to be a right triangle, and also we'd have a very hard time solving for these values if it wasn't. So put a little square angle marker in that bottom corner there showing that this is a right triangle. All right, let's start with the easiest thing to find, which is this angle here, B. There's something called the triangle sum postulate, which says that the interior angles of a triangle have to add up to be 180 degrees. So this here is 90 degrees. Let's go ahead and write this rule out. So triangle sum is that the interior angles of a triangle add to 180 degrees. So I've already got two of them, so I can find the last one using this, saying that 30 degrees plus 90 degrees plus angle B must be equal to 180. Add these two together, we get 120 plus angle B must equal 180. Subtract 120 from both sides. I get that angle B must be equal to 60 degrees. So this angle up here must be 60 degrees. We'll just go ahead and fill it in on the triangle. All right. Now we got to find one of these lengths, x and y. And that's going to require that we use a trigonometric function. So let's remind ourselves of what all of the trigonometric functions are. We have sine, cosine, and tangent. All right, and these functions, they take in an angle and then they give you a ratio of side lengths in a right triangle. So when we do sine of some angle theta, we always get the length of the opposite over the length of the hypotenuse. Cosine of theta always is going to give us adjacent over hypotenuse. And tangent of theta always gives us opposite over adjacent. All right, and there's an acronym we can use to remember this. It is SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Or you can say the mnemonic, some old hippie caught another hippie tripping on acid. It's one that I remembered for a long time, so I think it's pretty good. But for these to work, you need to pick one of your angles to be theta. It can't be both the 30 and the 60. And it's not allowed to be the 90, because from the 90, you would have a hard time deciding which side is opposite and which side is adjacent. So you can't pick the 90, you got to pick one of the other ones to be your theta or your reference angle. So I'll just pick the 30 down here. I'm going to put a little guy here because he is looking out at the other side lengths to decide which is opposite and which is adjacent. The side length opposite of our 90 degrees is always going to be the hypotenuse. All right, so x is the hypotenuse. That doesn't depend on which is our reference angle. That's just always our longest side. Now, from this guy's perspective, this side length over here would be the opposite. It is opposite of that 30-degree angle. And the only side length remaining has to be our only word remaining. This has got to be the adjacent here. All right, so from this 30, The 5 is the opposite, the y is the adjacent. All right, now I want to solve for one of these. I want to solve for this, actually I want to solve for the y first. So I need to use a side length that I know, which is this 5 over here, the opposite, and I want to solve for the adjacent. So I go look at these here, which of these includes both opposite and adjacent? It's tangent. So if I take the tangent of 30 degrees, when I plug this into the calculator, it's always going to give me the ratio of the opposite, which I'm just going to fill in as a 5 right now, over the adjacent, which is a y. All right. When I do this, let me pull up my on-screen calculator. I want to make sure that I'm in degree mode if I'm going to be plugging in degrees. If you're in radian mode, we're going to learn a lot more about radian later on, but that can really mess things up. So press this mode button on your calculator and make sure that this is switched over to degree, or else we're going to get the wrong numbers. Now I want to do the tangent of 30 degrees. So tangent of 30 equals 0.577. I can write that in here, but I'm going to keep it in my calculator so I can do the most precise math possible. Equals 5 over y. Now how do I solve for y? Well, I need to rearrange this. Multiply both sides by y. And I get 0.577 times y equals 5. Divide both sides by the 0.577. And we'll see that these two terms switched places. And I get y equals, now I want to do this in the calculator so I can preserve precision here. 5 divided by second answer gets me 8.66. So 8.66. And we don't have a unit here, but that's some sort of length unit for our y. All right. Now I could just do another trig operation, maybe with opposite and hypotenuse. So I would maybe do the sine of 30 to solve for the hypotenuse here. But now that I've got two lengths, I can bring in one last thing that I want us to remember about triangles, and that's the Pythagorean theorem. Now it's an O. Pythagorean theorem. Really famous one, a squared plus b squared equals c squared. This only works on right triangles. So looking at our right triangle here, the two legs have to be a and b. Doesn't matter how you label them. And the hypotenuse will be c, so 5 squared plus 8.66 squared. It's going to equal our hypotenuse x squared. And I'm just going to plug this whole thing into my calculator. And since I've got that 8.66 number still saved right there, I could just square it right off the bat. Plus 5 squared, is 25. Get exactly 100. So let me fill that in on this side. 100 equals x squared. Take the square root of both sides. And then we get that our hypotenuse must be 10. All right. So we have found all three angles, all three sides. This triangle is now solved. All right, I've got another triangle for you. Here you go. Quickly sketch it. I want you to try to solve this triangle, and solve means find all side lengths and angles. All right, so go ahead, try that on your own. I'm just going to work up this triangle by myself. We'll see if we get matching results. And this is a right triangle. You can go ahead and fill in that right angle marker there. All right, so And I'm done. All right, so you might be wondering how I solved this so quickly and without using any trig. Well, one thing is that when I realized that because this angle here is 90 and this one's 45, angle A over here must be 45 for these to add up to be 180. Then because these two angles match, this must be an isosceles triangle. Now I can draw little angle matching markers there, and these two sides have to match. Once I had the matching sides, I had enough information to do the Pythagorean theorem. And then the only tricky part was simplifying this radical over here, the square root of 128. You can split that 128 into a 64 and 2, and then that's 8 root 2 for the side length here. And since we had a unit on radicals, we better be simplifying our radicals. All right, here's another one that does require some of those trig operations. So to solve this one in your notes, I'll put up my work now. All right, and this triangle is solved. This length over here was 8 units. This length over here was 8 root 3 units. This length here was 16. And this angle here was 60 degrees. I found this angle first with that triangle sum. Then I used little right triangle trig to find this length over here, Pythagorean theorem to find this length here, and then simplified the square root of 192 into 8 root 3. Soon we're going to learn about special triangles. This 30, 60, 90 triangle is one of our special triangles, which will make finding these side lengths a little bit quicker. But for right now, we can find everything just using triangle sum postulate, Pythagorean theorem, and some trig operations. All right, goal for this lesson is to be able to identify the features of a periodic function. Why are we doing this? This is a new type of function that we'll be focusing on for this next unit. So, question for you, what do all of these have in common? Take a second to think about it. All right, I'll give away the answer. Is that everything we see here occurs in cycles, and its movement follows the same pattern over and over. The moon orbiting the Earth The lunar cycle follows the same pattern over and over. Waves follow the same pattern over and over, going up and down. Person on a swing set, a heartbeat, all of these things are periodic. So here's some vocab for you. A periodic function is a function that retraces the same y values over and over. One cycle is a complete set of y values that is being repeated. And a period is the distance on the x-axis of one cycle. All right, so for whenever I say cycle, I want you to think, pick a different color, y values. When I say period, I want you to think of x values. All right, so let's highlight one cycle and find the period here. So when I need to highlight a cycle, I need a complete set of y values that's being repeated. I can actually start anywhere on this this pattern here, but I always like to start at a maximum and then retrace until I reach that same maximum. Now it's possible for it to hit the maximum twice within one cycle, but that's more rare than hitting some midpoint twice within a cycle. All right, and then we double check. If I repeated this pattern, if I connected this piece right over here to the end over here, would I get back this next part of the pattern? And I would. So we couldn't stop any sooner than right here, or else if we kept repeating that, we'd be missing features here. So that there in green is one cycle. All right, and that's the whole set of y values from 1 down here to 0, back up to 1. All right, the period is just this distance here, from maximum back to maximum. And we go from 1 to 3. So the period is 2 units. All right, question, is this periodic? Well, it's oscillating back and forth, so it might be periodic. Take a guess now. No, this one is not periodic. It's not retracing the same y values each time. Unless this whole pattern restarts over here where we get these big waves again, and that's out of view, this is not going to be considered periodic. What about this one? Is this periodic? No, again, same problem. It is following a pattern, but it's not retracing the same y values. Even though we could take this piece and attach it to itself, it's got to start and end at the same y value. That's a feature of being periodic. What about this one? This one is a yes. It is retracing the same y values each cycle. All right, 2 more vocab words, then we're going to be done. Amplitude and sinusoidal axis. All right, we'll start with that sinusoidal axis. That's kind of a long word. There's a much simpler word for it, and that is the midline of our function. All right, and the midline, we'll give that a definition, is a horizontal line halfway between the max and the min of the function. So the max and the min, we'll say y value, y values of the function. All right, and if it's halfway, we can use a formula to get there, but I don't like you guys to memorize this formula. I think it's easier to just look at where the max is, look where the min is, and say where's halfway. but we could do max plus min divided by 2 to get halfway in between them. All right. So looking at this, the maximum y value we get is y equals 0. The minimum y value that we get is y equals -4. Halfway between 0 and -4 is -2. So I can add in a horizontal dotted line. Let me make that a little bit thicker. At -2, this is our sinusoidal axis or midline. Our y equals -2 is our midline. All right, now amplitude. Good definition for amplitude. It's the distance from the midline to either the max or min. And again, it has a formula that I don't think is super useful to memorize, but I'll give it to you anyway. So we want half of the distance between the max and the min. So what we're going to do is max minus the min to get the total distance and then divide that by 2. Notice these formulas are very similar to each other. They're easy to mix up. It's easier to draw a picture and just think these things through. But you can find the amplitude by always doing max minus min divided by 2. All right, so from this midline, how far do I have to go to get up to my maximum? What's that distance right there? That distance right there is my amplitude, and we can just count it 1, 2 units. So the amplitude equals 2 units. Let me see if I've got another slide here. Nope, just working the homework. For the homework help video, it's got a worksheet at the front that I didn't give you guys, so you can ignore that. Just started about at minute 8 on that homework help video. All right, have a great rest of your day.